Let us practice a nomenclature with some previously asked question in the board. So the question is, draw a structural formula of a compound with 2 carbon atoms. 2 carbon atoms in each of the following case. They are asking us to write a structural formula in which only and only 2 carbon atoms should be there. That means n equals to 2 we have to count. First one, alkene with carbon to carbon single bond. Now when we are writing homologous series of alkene, n equals to 2 will give us Cc and each carbon will contain a single bond. So it will be this H. So 2 carbon atoms surrounded by 3 hydrogen atoms. So what structural formula we will get here, condensed formula we will get is H3C, C double single bond and CH3. So this is ethane, but they have asked only for the structural formula, not for the name or condensed structure. So here we are going to write this structure. Next, an alcohol containing 2 carbon atoms. When any alcohol is attached with 2 carbon atom, so the second answer will be 2 carbon atom. At any place you can attach alcohol. OH is our alcohol group. So rest all you can fill with hydrogen. Right. So an alcohol containing 2 carbon atom is this. What is the name of this hydrocarbon? It is ethane and all. Ethanol. Third one. An unsaturated hydrocarbon. Unsaturated. What are the unsaturated hydrocarbons? Alkenes and alkynes. Those who are containing double bond and triple bond. With carbon to carbon triple bond. Here they have mentioned in between double bond and triple bond, they have mentioned that they want triple bond. So first we are going to write a bond in between carbon is triple bond. Now you have to fill the valency with hydrogen. So this is going to be ethene and ine. So ethyne, right? So all the structure, what all we have written is with 2 carbon atoms. But they have given one clue that which compound they want. So whenever you are writing or answering this kind of question, please highlight those words which are giving you clues. For example, 2 carbon atom, then this is a single bond, then alcohol and unsaturated with triple bond. So those things you have to understand and you have to write a structure accordingly. Let us see second question. If you are confident with nomenclature, then just pause the video, write down a question or see the question and try to write an answer. And if you have any doubt, please check out my explanation. What is the question? That ethane, ethene, ethanoic acid, ethyne and ethanol. From this name, these are the things what they are asking. The compound with OH and COOH. Compound with OH. OH is alcohol group. COOH. That group is carboxylic group. So the compound which contain OH will have OL afterwards. So that is OL is here. So it is ethanol. So the answer is, first is ethanol containing OH group. Second, COOH, that is carboxylic acid, and what suffix we are using for this is oic acid. So that is ethanoic acid. So the second answer is ethanoic acid with the group COOH. Now second, homolog with formula CnH2n. Homolog with this formula means which series is following this homologous formula. If you will see, this is CnH2n. This formula is from alkenes. So alkenes having suffix en. So which name is containing ene? That is ethene. So the name is ethene. Here alkene is not an answer. The answer is ethene. Unsaturated hydrocarbons. Generally they have asked, what are the unsaturated hydrocarbons? Alkenes and alkynes, double bonded and triple bonded. So from this you have to search which compound is double bond and which compound is triple bond. So this is alkene. So this is double bond. So the first one is ethene. That is with double bond and it is unsaturated. Then second, it is ethyne, it is alkyne with triple bond. So these two compounds are unsaturated hydrocarbons. And if they have asked for saturated one, ethane, then ethanol and ethanoic acid, they all are unsaturated hydrocarbons. And alcohol. Alcohol. What are the alcohols? They are containing OH group and the suffix will be OL. So here the same question. Here they have asked regarding the functional group or substitute group, but here they have asked with name. So it is important that you should know that OH is an alcohol and OL suffix will come. Carboxylic acid is COOH and oic acid suffix will come. Every detail you should remember. So an alcohol, that is ethanol. So answer will be ethanol. Third question. Give IUPAC names and functional group for the following compound. So this is first compound and second compound. Which two details they are asking? First is Iupac name and functional group. What are the functional group? OH, alcohol, COOH, carboxylic acid and so on. They are functional group. And they are asking IUPAC nomenclature. They are not asking a general names. So here first compound is CH3, CH2, CHO. As per our rules, first we are identifying the chain. So chain contain how many carbon atoms? 3 carbon atoms. So let us write first our root word, that is prop. Now when you are seeing this CHO, this is aldehyde group and the suffix come will propanol. Now propanol says that somewhere CHO group is there, but we have to identify where it is. So first, second and third, first, second and third, and we are always giving a smaller number to functional group. So here I am going to write 1 propanol. 1 propanol. Now second, first rule, identify the chain. So how many carbon atoms are there? 1, 2 and 3. Again it is going to be prop and then here OH group is there. So OH group is alcohol and suffix will come ON. So propanol. And here when we are counting this 1, 2 and 3, 1, 2 and 3, we are going the smaller number to this alcohol group. This means you can also write that here also OH group is present. So OH group is attached with this carbon only, not with this and not with this. So we are giving one number to this carbon atom and not to this and not to this. So here we are giving 1 propanol. Fourth question. Draw structural formula of ethyne. So we have to draw a structural formula, and that too ethyne. Ethyne is from alkynes, so it must contain triple bond. And one more thing, that eth is a root word where C equals to 2 will be there. So we have to write a structural formula of a compound which contain 2 carbon atom and they are connecting with triple bond. Then only it can be ethyne. Yne suffix comes with alkyne series. And the rest all you have to fill it with hydrogen. So this is how we are writing a structure when they are giving a name. How the structure of alkenes and alkynes are different. Here this is alkenes and here this is alkynes. How they are different? Different means alkenes are containing double bonded compounds, whereas alkynes are containing triple bonded compound. And one more difference for its homologous series. The homologous series for alkene is CnH2n, whereas alkyne is CnH2n minus 2. So these are two difference in between alkene and alkyne. These are double bonded with this homologous formula. These are triple bonded compounds with this homologous formula. Double bond between which atom? Carbon-carbon double bond and carbon-carbon triple bond. Now they have also asked how they are same. So what are the similarities between alkenes and alkynes? So first thing, they are unsaturated. And the second thing, they can go for addition reaction. So these are the similarities between alkenes and alkynes, that they are unsaturated hydrocarbons and they are allowing addition reaction on them. Fifth question, fill in the blanks. Alkenes are the homologous, analogous series of blank saturated, unsaturated hydrocarbons. They differ from alkenes due to the presence of double or single bonds. Alkenes mainly undergo addition or substitute reaction. Now let us see the fill in the blanks. Alkenes are the analogous or homologous series of, so it is going to be homologous. It is homologous series of saturated, unsaturated. They are unsaturated. Alkenes and alkynes are unsaturated, whereas alkanes are saturated. Hydrocarbons, they differ from alkanes. Here they have given alkanes. Alkanes are single bonded compound. Due to the presence of which double or single, they have asked that alkenes are differing from alkanes. So you have to write double bond. If they have changed the sentence that alkanes are differing from alkenes due to single bond, because alkanes are having single bond whereas alkenes are having double bond. You have to answer it very carefully and you have to read the sentence carefully. If by mistake you are taking here single, then it is going to be wrong. Alkenes mainly undergo. So alkenes are having a double bond and one double bond will go off when we are adding hydrogen or any functional group. So they are keep on undergoing addition reaction. So addition is the answer. Sixth question. Write IUPAC names for these three compounds. First compound. So as per our rule, we have to identify first a long chain of a carbon atom. Second, whether there is any double bond or triple bond. And third, if there is no double bond and triple bond, whether any functional group is there or not. So these three basic rules will keep in your mind and will write the names for them. So first, let us identify the chain. There are 1, 2 and 3 carbon atoms. So the root word what we are going to use is prop. Now there is a triple bond here. So it is from the group of alkyne. So this is prop and YNE suffix will come because of this triple bond. So the name is going to be propyne. YNE. So the name is propyne. Now whenever we are writing a name with double bond, triple bond and a functional group, we have to suggest that where they are located, on which carbon atom. Till 2 carbon atom there is no need to give numbering, but if it starts from 3, suppose propyne, then we have to give a number. So here obviously we are giving a small number to triple bond. So I am going to write here 1 propyne. Second, identify the carbon atom. 1, 2, 3, 4 and 5. So root word what we are going to use is pent. Now if you will see, there is no double bond and triple bond. But yes, functional group is there. Which functional group is there? OH. So it is alcohol. Alcohol is there. So suffix we are using is OL. So this name is going to be pentanone. Whenever we are writing a functional group, also we have to write a number for it, that where that functional group has been located on this carbon chain. So 1, 2, 3, 4 and 5. Always keep in mind that whenever it is a chain of odd number carbon atom and it is in the middle, if you are writing from right to left or left to right, the same number is going to come. So it will save your time. Whenever it is in the middle, only one number will come. If it is 3, then 2. If it is 5, then 3 and so on. So it is 3-pentanone. Now the third one. Identify the carbon chain 1, 2 and 3. So the root word what we are going to use is prop. Now see, this methyl group is attached at this second carbon atom. What is our methane? It is CH4. When one hydrogen atom is less from this, it is going to be an alkyl group. So CH3 is known as methyl. This is methane. This is known as alkyl group methyl. So this methyl group, this is CH3. Methyl group is attached at this second carbon atom. So whenever methyl group is there, we have to write methyl as a prefix. So here I am writing methyl. So on which carbon atom? 1, 2, 3. So it is 2-methyl propane, because all are single bond. So it is propane. It suggests that there is a 3 carbon atom in a chain, and at the second position the methyl group is attached. Some more compounds. This structure is with 2 carbon atom, and which functional group is here attached? It is C with double bond O and another OH. So this structure is giving us COOH. So this is carboxylic acid group attached over here with 1 carbon. So first we are identifying the chain. So 1 and 2. So the root word comes will be eth. And since carboxylic acid is attached over here, the name comes will be ethanoic acid. Because for carboxylic acid, oic acid will be the suffix. Now we have to write that where this group is attached. So this group is attached over one carbon atom. So whenever it is ethanoic acid, no need to give a numbering because it is only 2 carbon atom and it is always going to attach with the rest remaining 1 carbon atom. So it is ethanoic acid. Now fifth one. If you will see this structure, there are 2 functional group, 2 chlorine is there and here 2 carbon atom is there. So let us write eth as our root word and this is ethane because all the bonds are single. So it is going to be ethane. Now let us give numbers to this to show where this 2 chlorine functional group is attached. So this is 1 and this is 2. If you are writing other way 1 and 2, then also the numbering comes will be same. So we are writing 1 chlorine functional group is attached over this carbon and another with this. So we have to write both 1, 2 chloroethene. So it suggests that 1, 2 and we are writing here di. It says that there are 2 chlorine group is attached over ethane and both are not at the same position. They are at the different position. So the name will be 1,2-dichloroethane. Suppose this both chlorine group at the same carbon atom. For example, like this, and rest all are the hydrogen. Then we are going to write 1 here. So the name will be 1,1-dichloroethane. Here we are giving smallest possible number to functional group. Both are attached at first carbon atom and they are 2. So we are writing di. So that's why 1,1-dichloroethane. We are giving 1 and 1. 1 and 1 for both the chlorine group. So 1,1-dichloroethane. 7th question. In this they have given this table where they have given general formula. First column it is CnH2n, second CnH2n minus 2 and the last one CnH2n plus 2. And these are the rows which we need to answer for these 3 columns. So first thing, IUPAC name of homologous series. So what are the homologous series? Alkane, alkene and alkynes. So here you have to identify that which homologous formula is this. It is CnH2n. So it is for alkenes. Then it is CnH2n minus 2. So it is for alkynes. Then it is CnH2n plus 2. So it is for alkenes. Second one is bond type. That means they are asking for, if it is alkenes, which type of bond will be there in between carbon and carbon. When it is alkene, it is carbon-carbon double bond. When it is alkynes, it is carbon-carbon triple bond. And when it is alkene, carbon-carbon single bond will be there. Now the third one, first member of series. So in alkenes, what is the first member? It is non-corresponding hydrocarbon. It is non-corresponding hydrocarbon because as per this formula, if we will keep n equals to 1, we have not been able to get a stable structure. Then the same way, alkynes, it is non-corresponding hydrocarbon. So first member for alkene and alkyne is not possible. Now for alkanes, the first member is methane and the molecular formula will be CH4. Type of reaction with chlorine. So when chlorine is reacting with any of the alkenes. Now alkenes and alkynes both are unsaturated. So they both will go for addition reaction. So whenever we are adding a chlorine, it always go as addition reaction. So alkene and alkyne both will go for addition reaction. Now alkanes are saturated compounds. So if you want to add something, you have to replace one of the hydrogen from it. So it is always go as replaceable. So it is known as substitute reaction. So it is substitution reaction. So this is the basic difference between unsaturated and saturated hydrocarbons. Now 8th question. Find the odd one out in this 2 question. So first one, they have given some molecular formulas. First one is C3H8, C5H10, C2H6 and CH4. We have to find out the odd one out. If you remember the homologous formula for alkane, alkene and alkyne, then it will be easy. If not, then we have to write a structural formula for each and every compound. So this is C3 and H8. So 1, 2, 3, 4, 5, 6, 7, 8. So this is coming in alkane series. Let us take this. In this C5 is there. So C1, C2, C3, C4, C5. Now how many hydrogens are there? 10 hydrogen. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and only 10 is there. So here we are going to keep a double bond and here one more hydrogen we have to keep to satisfy 4 valency of this both carbon. So this is going to alkene. Now let us take the third example. That is C2H6. 2C and there are how many hydrogens? 3 hydrogen. So this is again alkene. And the last one is CH4. Obviously it is alkane, it is methane. So if you see, this all 4 are single bonded, where only this is alkene and it is double bonded hydrocarbon. So this is going to be odd one out. And what is the reason going to be? Reason is among all the alkane, this is the only alkene with double bonded hydrocarbon. Now let us take the second one. In this they have given some acids. Which acid is odd one out? First one is formic acid, then nitric acid, acetic acid and propanoic acid. If you will see, formic acid, acetic acid and propanoic acid all are hydrocarbon, where this is nitric acid is HNO3 and it is inorganic acid. These all are organic, whereas only this is inorganic. So this is going to be odd one out. 9th question. Give structural formula for first methanoic acid, ethanol, ethyne, acetone and 2-methyl propane. Let us start with methanoic acid. So when the name is there and we have to write a structure, first we'll identify a root word. So here they have given meth. So it is about only one carbon atom. And oic acid is there. So carboxylic acid will be attached as a functional group. So this is our carboxylic acid group. This C with double bond along with oxygen and OH group will be there. If you will see, then only one valency will be left for the carbon. So this is going to be a methanoic acid. Now ethanol. So the root word is eth. So it is going to be 2 carbon atom, and now see the suffix. It is Al. Al, so they are suggesting that aldehyde group is present in this. So when it is aldehyde group, it is CHO will be there, and this is going to attach here, and here 3 hydrogen will be there. So this is ethanol. And what will be the structure of this aldehyde? C is attached with double bond and 1 hydrogen. So here 3 bond is already occupied. So no more hydrogen will come here. This carbon is already attached with another carbon. Now ethane. So the root word is eth. So 2 carbon atom will come, and here we can see YNE. This is a suffix for alkynes, and they are triple bonded compound. So here we have to make triple bond in between 2 carbon. Now rest all valency we have to fill with hydrogen atom. So this structure is for ethane. Now acetone. Acetone is from ketone functional group. So ketone functional group will come in between, and this is a regular name or generic name. The IUPAC name is dimethyl ketone. So dimethyl, so this is a methyl group at one side, and another side it is going to be another methyl group. So it is dimethyl ketone, and that is known as acetone. Acetone is a generic name. Now fifth one, 2-methyl propane. So here first identify the carbon chain. It is propane. So 3 carbon atoms should be there, and 2-methyl is there. 2-methyl means 1 methyl group is attached over second carbon. Rest all you have to fill with the hydrogen. So this 3 hydrogen, and here 1 more hydrogen will come. So this is 2-methyl propane. So this is first and second. This is second carbon where the methyl group is attached, and the other 2 carbon will attached with 3 different hydrogen. So 10th question. Write IUPAC names for all this 3 structure. First structure. In the first structure, the long chain is consisting of 3 carbon atoms. 1, 2 and 3. So the root word what we are using here will be prop. And if you will see here, there is a double bond. So it is going to be an alkene series. So here we are going to write ene as a suffix. So it will be propene. And whenever we are writing a double bond and triple bond homologous series, we have to also identify that where that double bond is. So we are going to number it 1, 2, 3. So it is at the first carbon position. So I am writing here 1. So what this name suggests? It is suggesting that it is propene. That means there are 3 carbon atoms with 1 double bond, and where that double bond is? At the first place of carbon. Now second, as per our rule, first we are identifying the chain. So how many carbon atoms are there? 1, 2, 3 and 4. So wherever it is 4, the root word we are using is but. And here if you will see, there are triple bond. So it is triple bond, and suffix we are using is YNE. So it is going to be butyne. And again we are going to find out that where that double bond is there. So we are numbering it 1, 2, 3, 4 and the reverse size, and we are going to see that which number is the smallest one. At both the side we are getting 2 number for that bond. So it is 2 butyne. there are 2 carbon atom with a functional group CHO. Wherever it is CHO, it is aldehyde group. In aldehyde group, carbon is attached with oxygen with double bond and hydrogen with single bond. So there are 2 carbon atoms, so it is going to be eth. And aldehyde group is there, so Al suffix will come, so it is going to be ethanol. 11th question. Give structural formula for these 3 compounds. First one is 2-methyl propane. So whenever they are giving a name like this, first we are identifying a long chain. So the last word suggests us that it is a propane. Propane is consisting 3 carbon atom. So these are 3 carbon atom which is going to make propane. Now they are also saying that it is 2-methyl. That means at the second carbon methyl group is attached. This is our second carbon and there methyl group is attached. Methyl group is CH3. Now rest all carbon and the remaining valency we are filling up by the hydrogen. So there will be 3 hydrogen here. Here 3 bonds are already there. So 1 H will come here and here again 3 more H will come to satisfy 4 covalent bond of carbon. So this is going to be 2-methyl propane. Now second, ethanoic acid. If you will see here oic acid, this suggests us that there is a carboxylic group attached with eth. Eth suggests that there is 2 carbon atom, and ethanoic acid says that at 1 carbon atom it is carboxylic acid group. This is our carboxylic acid group. C is connected with oxygen with 2 bond and 1 bond with OH group. So rest all we are filling up with the hydrogen. So here 3 hydrogen will come, and if you will see here all the 4 bonds are completed. So there is no need to add any hydrogen here. So this is our ethanoic acid. Now the third structure. It is butane to all. So that means this is a long chain consisting of 4 carbon atom, and all means somewhere alcohol group is there. So let us first write 4 carbon atom and then somewhere alcohol group is there. So this 2 suggests us that at the second position of carbon OH group is attached. Now this makes our structure of butane to all. Butanol is the another name, and butane to all is also a name of same structure. So rest all valency we are filling up with the hydrogen. So this is our butanol or butane to all.